for another C++ San Diego C++ meetup. I'm trying to see if my son joined. He did not join, unfortunately. That's a shame. I was looking forward for him to join. So anyway, this is our 30th meetup. So this is a big milestone for us. Let me just go to presenter mode. Okay, so first of all, again, I would like to acknowledge Qualcomm. I'm part of Qualcomm WRD software. Thank you so much for helping me on that, and the meetup fees are paid by Qualcomm WRD software. Especially, I would like to thank my VP Charles Bergan. He's a big supporter of this effort. So thank you, Charles, for that. For your ongoing. It's more than a year and a half of that. So thanks again. I just wonder, I think I've seen few people which are new. Can you please raise your hand if you are new? Yeah, there's this feature where you can raise your hand. Okay, Joe, thank you for coming. Nice meeting you. Nice meeting you, Joe. Alex,
Thanks.
hey, and Christian. Are you guys from San Diego?
No, I'm from Atlanta, Georgia.
Oh, cool. So not in the same time zone, but thank you for joining. I'm trying to make it kind of earlier, so other people from other time zone in US, at least in US, can join. We used to do it in 6 p.m. Pacific, but it was actually late for me as well, like 6 to 8, but 5 to 7 is much better. Welcome. Happy to have you. Who's else? So who was it? It was Joe that was speaking right now. So Alex,
Yep.
it was you. No, Joe.
Yep. Sorry, that was me, Joe, speaking. Yeah, thanks for putting this together. I really appreciate it. Looking forward to, I really like the agenda. So, yeah, thank you.
Hopefully you'd like it. Yeah, thanks. My pleasure. Christian and Alex. Alex, are you San Diego location or different location? I know I can't hear. I don't know if you're muted, but anyway, thank you for coming. I appreciate that. Um, we have a busy agenda as always. I'm usually putting that on my spare time, not usually, always on my spare time during weekend, and I'm trying to make it very uh, fun. I think the fun part is the most important thing here. I'm trying to make it very informal and kind of casual, and my my main goal is that we, after maybe an hour and a half, we all learn something new. I know that when I prepared the agenda, looking for all kinds of topics and all, I learn new stuff, and I hope that you would learn new stuff as well. So we have C++ quiz. We have a new library that captured my eyes that I wanted to share with you. We have a Stackoverflow question of the month. We have two books that I would like to recommend. We have this old school versus new school template type restrictions. It's kind of a light intro to concept by Martin and myself. Um, it's very light. It's kind of intro to concept, but it would give you a lot of information to start with. And it's based by Martin's. What gave me the idea was Martin's recent post in his website. So hopefully you like it. Martin is going to join in a few minutes if he didn't yet. Um, if time permits, which I believe we don't have time for today, but I have some past books that I wanted to share with you. But again, I don't know if we have, and then some Wallet Fox slides that we might have time today. Okay, so let's let's go to the next one. Yeah, sponsored by Qualcomm. Thank you again, Qualcomm, for that. We have a Dropbox. We have a Slack channel. Yesterday, I created Discord. I told my kids, I have two teenagers. Well, I have teenagers. One is 18 and a half, almost 19, and one is 16 and a half, and told me, do you understand what you're doing? Because Discord means you need to have rules and you need to have channels and all of that, and you need to maintain that. And say, yeah, I understand, but it's too much work. So we'll see. But you can join. I posted the link in the meetup.com, our meetup.com. So there is a message there. So if you click it, I think you should be able to join. Let me know if you can't. We have the SDCPPU CPP Meetup YouTube channel. I'm uploading the content, so be aware that everything here is uploaded and shared with you. We have a Twitter handle, SDCPP Meetup, and my handle is Kobi_CA, and I only tweet about technical stuff, so no politics and similar. Though it sometimes tickles in my fingers, I make sure that there is no politics. It's only technical stuff. So you can follow me if you want to. Okay, we have few jobs. I know there is someone. Let me see if he's here. You are here. So before we go to Qualcomm, there is a request to post jobs. Bin Long, am I pronouncing your name correctly? There is a echo feedback that. Can you hear me? Can you hear me?
Yes, I can. Yes, I can. Yes, I can. Yes, I can. Yes, I can.
Okay, you need to get your audio straight because you're presenting one slide. So can you make it? Bing Long? Okay, let's do this. Let me continue and stop me anytime. We'll get your posting. Okay. I don't know if you can hear me, but I'm just gonna continue and just let me know when you're ready. I'm gonna stop and we get your posting in. So I have a lot of stuff happening in Qualcomm, a lot of interesting stuff that I would like to share with you. I got that from hiring managers in Qualcomm, especially from my department, but I'm not sure if it's only from my department. They kind of collected that for me. So thank you from I would like to thank this hiring manager doing it for me. So we have a few firmware related from L1, G-Node-B embedded software developers. There's a physical layer, which is basically also L1, and firmware engineers, all in San Diego. We have things related to CSM embedded software. By the way, this is all public links, and I would post it, and you can just apply by clicking. It's all external Qualcomm links. So I encourage you, if you're looking for a job, I encourage you to take a look at that. We have L2, L3 software engineering. We have a lot of L2, L3 on the network side. So take a look at that as well. And also ML related software engineer Rex. Lots of tools. By the way, I'm a big fan of tools. Some of the people that working with me knows that I really like tools. So there's a lot of tools opening. So also highly recommend that. And there is a couple things. One is an internship. So click on if you are looking for an internship. I believe we start looking at this time. This is why I received that. And also recent grads, take a look at this posting. Yeah, so ping me if you need anything. If you need any context on and all, let me know. I can help you with, and the Dropbox would have it. Okay, so that's Bing Long. You have anything that you can share?
Yeah, I am trying to share.
Okay, you need me to stop sharing. So let me stop share. Now you can take over, hopefully.
Okay, can you see the screen share?
Yeah.
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 So, first of all, you guys can hear me, right?
Not very well. You have echo, but that's fine. We'll do it quick.
Okay. So this is an embedded C++ software engineer position for immediate opening at Apple in San Diego site. This is a runtime calibration service for computer vision algorithms on Apple's next generation of devices.
Okay.
Mostly working on embedded constrained environment. So therefore, the efficiency of the code is required, right? We mostly use modern, solid, efficient concurrent C++ programming here. We have the job description posted at the public jobs website at Apple. The roll number is 2002-83430. If you get this number, you can search at jobs.apple.com for this position. And you can also contact me. My name is Binglong Shai. And if you search my name at LinkedIn, you should be able to find me and you can try to connect to me. Any questions on this?
Thank you, Binglong. Am I pronouncing your name correctly, by the way?
That's great. Yeah.
Okay, good for me. I
Thanks.
sometimes butcher the names. I'm sorry about it sometimes. I'm happy that this is not the case.
Yeah, my first name is actually relatively easy to pronounce in Chinese names. My last name is not.
How do you pronounce your last name?
It's something like a Shay.
Shay. Okay. Binglong Shay. Thank you.
Thanks.
Okay. I'll go back to my agenda. Let me see. Okay, I need to probably do something like I'm not sharing right now, huh? I don't know what I'm sharing. Okay. So let me do this and just flip. 1 second. Okay, we are back to business. Okay, now the meat of the agenda would be learning stuff in C++. So let's start with the first quiz. Okay, let me open it and I'll share it in a second, okay? Okay. Okay. So I would start by saying that this is a very interesting question to take a look. Take a few seconds to look at it. It is difficulty 3 for a reason. Anyone actually kind of recognizing this pattern? Yeah, I must say this should look very strange because there is a while loop. There is a do while loop internally inside the switch. It's totally, well, I don't want to say because then it's one of the, so there are options. If you knew, there's options, either it's compilation error, unspecified, given defined, or guaranteed to output, or undefined. So there are 4 options. What do you think? So there is this kind of trick that I've learned a few years ago, not a lot of years ago, maybe 3-4 years ago. First time in my career that I was actually bumped into this this mechanism or trick. kind of an optimization of switch case. But what do you think would happen here? Any suggestions? First of all, is it gonna compile? Is it undefined, unspecified? What do you think? It's fine to be wrong. It's actually a very difficult question. Okay, so the hint is that it's gonna compile, and there is a specified output here. So that's so we ruled out all the other three. So let's take a look what's happening here. N is 3, I is 0. There is a switch with 2 case, no default, but just 2 case, and there is a do while. The do starts at the 0, and the while is after the case 1. So it looks very, very weird, and indentation is not actually happening here. But okay, so let's do it together. So n is 3, so n modulo 2 would be
1.
That's easy, 1. Okay, so I need someone to count the I for me. So we have I plus plus. We have plus plus I, which means I is 1. Then we go here and we have this while, and then minus minus n. So n was 3, right? So minus would be 2. It's still more than 0. And then we go to the do, because we are inside a do while. It doesn't matter that we started with the switch. The switch is like, you can think about it like there was a go to, and now we do some hey Martin, we do some iteration now. So now I is plus plus, so I is 2. We again do case 1 because it's just the regular flow, right? And then plus plus I, so I is now 3. Just make sure that I count correct. N was 2. Now it's minus minus, so it's 1, but it's still bigger than 0. Then we'll do again plus plus and plus plus. N now would be 0. It's not bigger than 0. Then we break. So how much is I?
5, I think.
Right.
So I'm sorry, I'm really curious. So basically, like as soon as
it's a very tricky, and I would like to show you. So the whole thing is what we call Duff's device, and there is a link to Wikipedia. And what I wanted to show you, and this is what like a few years ago when I first bumped into that, and I think I was either through some Twitter post or that, I was completely amazed that this is actually a kind of doable or kosher thing to do. The idea here is kind of like, I'm not going to read the whole Wikipedia page, but take a look at this part, which is basically a way to copy, it's a kind of unroll loop. So take a look at, I want to copy from to the 2. So what is happening here, you take the count plus 7 divided by n, then you have this n, okay? And then you take this count, and modulo 8 would give you where you are in like, you need to have this amount of numbers, this amount of 8s. So you go into whatever the count is. If the count is 5, you go here and you start running the remaining, and then the full 8 numbers until n is done. It's basically, if you read, it's basically kind of an optimization. But the whole idea is that you can basically have a do while loop inside a switch case. I never seen it in a live production code, but it doesn't mean that it's not there. It's probably I don't know if a more advanced compilers actually maybe doing something similar, so you don't need to do it like manually, but maybe before it used to be the case. So so that's the whole idea. So again, you can think about switch case as, okay, I have these labels that I can go to and I can run. Now, if I hit this while, I'll start running this do while loop as if I'm not inside a switch case anymore. So that's the whole point. The switch is where I'm kind of jumping. It's like think about like a table that I can jump into some label, and then from that point, I'm just, there is no break. You can see it, so it's falling back, and then this while loop would do whatever it needs to do.
Yeah, I'm
So
noticing that. It feels like as soon as we entered the switch statement, you can kind of imagine the switch statement and all of these case statements just disappear. And
yeah,
right.
Yeah. Again, the idea is that you, I wanted to introduce that if you see it in either books or you see it in code, you understand what's happening here. So hopefully that's helpful. Okay. The next one. Okay. What is the output of this program? And again, is there an output or there's a compilation error or it's unspecified and so on and so forth?
My guess is this won't compile because you're using the strict constructor arguments, and it's gonna. Well, I'm sorry, never mind. That's my guess, but I'm not sure that's right anymore.
So the hint is this type is an aggregate in C++, which means we can initialize it in a very convenient way. It's convenient for me. I don't know. People might say that it's not convenient, but it is very convenient for me to initialize an aggregate. This is why I really like aggregates. They are very kind of easy to deal with. But the question is, we have 3 members and we initialize 2 of them. What happens? Is it would the compiler say, hey, you're initializing 2 out of 3, go initialize your 3rd one? I don't know what to do with it. Or maybe the compiler say there are rules that says, okay, it is fine and it's initialized to X, or it's uninitialized. So what do you think? The funny part, if it was my question, by the way, I wouldn't say S.1, I would say S.3, because I think, let's say it's compiling. What would be 3? Would it be uninitialized? Would be initialized? So I think that would be the interesting part. So first of all, it is compiling. It's conforming and all. It's not undefined and all. The question is, what is S.1? S.1 is basically 1. But the question is, what is S.3? This is I think the more interesting part. What do you think is S.3?
Is it undefined behavior?
No, if it was undefined behavior, we would need to pick this one.
I think it is defined.
It is defined. If we were picking
Right.
undefined, so we would do this. But it's actually defined, very defined in the standard, and it's an aggregate, and there are rules. And the question is, what 3 would have? Is it uninitialized, or is it something else?
Can I answer?
Yeah.
All right. Yeah, it will be 0.
It would be
because
0.
It would be default initialized, or in this case, because it's a primitive, its bits would be cleared. So anything not any field not initialized in the aggregate initializer is default initialized afterwards.
Right.
So in case of an int, the default constructor for an int now with the curly brace initializes it to 0.
Correct. And I mentioned aggregate. Here's the rules for aggregate. I think this would be, I think it changed a bit. So C++ 17 would be this one. I think they relaxed it a bit on 14. I don't remember what changes of 17, but I know that between 11 and 14 there was some relaxation. I think even 17 had some relaxed rules about aggregate. So anyway, just like Martin said, it is going to be defaulted to 0. It's an integer. Okay, so let's go to the next one. By the way, this is a very what we just saw on this question is a very common thing to initialize and this is okay to initialize up to a specific certain of numbers. The interesting part that people forget is if you want to initialize something to 0, like you have an aggregate or an array, which is basically an aggregate. If you want to initialize it with 0, you can just put 0. If you want to initialize to 1, having just a single 1 would not make all elements as 1. Or you want to make it 17, it's not going to make all the elements 17. It will make only the first one as a 17, and the rest would be 0. So just to remember that there is no such thing where I want to initialize everything to a specific number and just I'm using these curly braces and it's done. You need to use std fill or something like that that would help you to do that. There is a very interesting extension. I think it's an extension where you can actually say, I want to initialize from this index to this index. I want to initialize with this number. Anyone familiar with this? No? If you Google for that and you find, let me know. You can paste it. You can paste it into the chat, and I can present that. There is a way we can say from index 7 to index 10. This would be it's going to be initialized to this. It's kind of an extension, if I'm not mistaken. I don't think it's a standard. And I was attending a very good CPPCon talk in CPPCon 2019, and there was a talk about I can't remember the name of the guy that actually had it. So sorry about it. It would come to me later. But he had a very fun talk about all the non-standard and hidden features of C++, and also a bit about C. Some of them are kind of C as well. So that was one of them. It was very entertaining one. So if you are, and I'll find it online. I'll let you know but I think it's a very entertaining one. Okay.
You guys, can you hear me?
Yes.
So basically, for the initializer, you inside the curly braces, so you can use something like .1 equals 1, comma, .2 equals 2. So this way you'll know what fields you're initializing.
Designated initializer,
yeah. So, but that you cannot change the order. You cannot put like .2 equals 2 and then .1 equals 1. So the order should be exact.
And this was an extension, and I think, Martin, remind me, this was brought up in 20?
Yeah, I think so. I think that was brought up in 20.
20, yeah.
Speaking of the
finally.
initializer, yeah, I just wanted to throw in something real quick. So I had somebody approached me at work a few days ago with a bug, and what the code was doing, it was std string s for variable name equals, and then open curly brace 0 and close curly brace semicolon. And then the next statement would append to this string with a plus equals operator. And the person asked me, it's not printing what I'm appending. But when I remove the curly brace with a 0, it works. So what was happening was that it wasn't an aggregate initializer, and it wasn't initializing a string to a length 0. It was actually selecting the initializer list, and it was creating a string of length 1 with first character being null. So then appending to it and putting it out to the console had no effect, because whatever was passed in null was no longer being printed. So I just wanted to throw this in. I thought it was very interesting.
This one.
There was an equals sign actually between S and the curly brace, but I'm not sure if that makes a difference.
It doesn't make a difference. This is one of the there is the CP people in the Twitter. So one of them most kind of a bummer in stud string. This is actually an undefined behavior, if I'm not mistaken, to do something with, like to do a data append or something like that. Because it's just like you said, it's like it's basically, this is just similar to this. I think so, or I think it was like this. I can't remember exactly. I think it was more. I think it was null pointer, right? Because there is a character pointer that is taking it, and yeah, it's very common issue that I've seen. I never seen that in real life, just by people like you, Martin, that had this experience with code reviews.
Just so I'm clear, so there are bytes past the null terminator in this string. It's just that when we print, basically std cout is not going to print anything past that null terminator.
That's correct. Yeah, it's perfectly legal to have nulls in the middle of a string.
Yeah,
but it's when we're using some standard mechanism of outputting it to the console that will stop on the first null.
Yeah. Okay. So the next one is like I think this is the last one. Take a look at it. So we have two foo. One is a static inside the struct, and one is outside, let's say, global namespace. We have a main, and we call foo bar foo. So has foo bar x, sorry, and foo bar x is a static that initialized this way. So the question is, are we going to have, so it's initialized to something. Are we going to initialize to 11 or 10? It's all about which function would be picked by the compiler. Is that the one in the internal scope or the outer scope of the struct foo bar? Take a guess. Why do you think that it's more like more kind of a common sense to have?
My guess is 10 because there's no namespace when we call the function foo.
Okay.
Yep.
Anything else? Like the 11 is the other one. So
I
actually
agree.
the answer is 11. What? It says, yeah. When I said to myself a common sense, I said, okay, I should never say common sense because there is no common sense in C++. Some people would think about one way and the other one would think about, because I actually guessed it, and I guessed it correctly because I said, okay, the compiler would look at the inner space, because the way if you think about even ADL and things like that, they start with the most inner scope, and if they don't find anything, they start looking at an outer scope until, let's say, they stop at a specific point where they find something, or they stop at the global namespace. So that's why when I guessed it, I guessed it 11 because of this, because I thought, okay, this is how other things work, so I'll do the same. So that's unfortunately it's 11, but it's true for everything.
It's a bit confusing, actually. We don't have any instance of the structure, so you would expect that it gets replaced by 10.
Yeah, there is no instance, but there is a type.
Okay.
Okay. And actually, I realized that I skipped this one, so this one would be the last one. What I'm saying is that don't write such code to confuse people. That's one thing. And don't write, I don't know, here it's kosher, but I don't know, maybe add the 0 for people to have clarity. And don't use daf device unless you really want, or you want to obfuscate your code. That's also fine. Okay, this is the last one. This is actually a fun one. There are 3 constructors. One is a default, no constructor, no parameters. One is a single parameter, is an integer, and one is initialize a list of int. So we have this A1, A2, A3, A4. What would be the numbers? Okay, let's start with A1. First of all, it would compile and all. Let's start with A1. So what A1 would have?
One.
It's a default, so it's 1. Okay, the default constructor should be pretty easy. Then we have A2 with curly braces. What does it do?
1.
Sorry, 1? Okay, let's try 1. Why, by the way? Why 1?
I assume because we're passing in no parameters, it's going to use the constructor that matches the no parameters.
Okay, that makes sense. That makes a lot of sense. Okay. Other people would say, why? What about an empty initializer list? That's also a valid question. But let's start with 1. Okay. We don't know yet. I'm not saying it's an empty initializer list. I have a tweak at the end, so let's wait for that. Let's do 1 for a second. Okay. How about 1? Here, A3 with 1. So obviously the question is it going to take the int or is it going to take the initializer list? Now, if you read at least one other article or talk or watch the talk about initializer list in a constructor, you know something very unique in initializer list that is actually, it's a big mess, but you know something about it. So you would know what to do here. It is confusing, by the way, but it's completely standard. If you look at take a look at string and vector, they all have initializer list as they have a constructor with initializer list. So it's pretty kosher to have an overload of your constructor with initializer list, but it's confusing unless you know what's happening. So what do you think would happen here? Is it 2 or 3?
I would think it's 3.
It's 3. Now I always say that this is true, and the reason is that if you have initializer list, it's preferred. The constructor is preferred. Okay, so just remember that it's preferred over the integer. Now, if I don't have initializer list constructor, so yeah, it would be 2. Okay, and the last one is 1 and 2. What it would be? Should be easy. Let's say it's compiling, should be easy.
Gotta be 3.
Gotta be 3. Okay, let's take a look. Now it's true. So I already told you about the priority or preference about the initializer list. Now, I want to make a tweak here and take a look at A2 for a second, because A2 is really 1. It means that it's not looking, it doesn't look like an empty initializer list. Okay, so let me take a look at, go here and paste it here. Okay, so we should be able to see 1133 because we already verified it. It's true. Okay, if you don't know, this is Compiler Explorer, God Bolt, and so on and so forth. Or if you should be able to know about it if you following us. Okay, so I'm not using any compiler options here. It doesn't matter. So 1133. Now here's the thing. What do you think would happen? I don't want it. Okay, what would happen if I do this? Instead of curly braces, I would have a parenthesis and curly braces. What do you think would happen?
Then you would get 2, because the curly braces the regular braces override the selection of the initializer list, I think. Or
so,
no,
not 2.
Yeah.
So either it's 1.
So
2. Yeah. So let's take a look. So the question, it was 1. Now it's 3. What happened here is that what I'm telling the constructor is, look, I have this call to the constructor and I have an empty initializer list. This is the confusing part. Now, when I prepare this quiz, and what I do usually, I just randomly getting these questions and I just put them on the slide. I try it myself and learn and all, and trying to kind of explain that later. It just happened to I just happened to see a post or a Twitter post from one person that I think he's from Europe, he's from Switzerland, that I'm following, and there was a huge discussion about, again, the same deal about like the mess about curly braces and parentheses and all of that. And he said, if you have this question about, oh, is it a default constructor, or is it gonna take the initializer list with an empty? If you wanted the initializer list with an empty and you don't want other people to get confused with this, or you don't want yourself to be confused, just use parentheses. When I said, oh, that's actually a very good suggestion, because this actually remove ambiguity. Now you know that I'm actually calling a constructor, and inside I have an empty initializer list. And I thought that this actually makes sense. And I tried it, and it worked well for me to kind of explain that it changed. But the thing is, on the flip side, removing parentheses actually gives you a complete different constructor, which is kind of scary. Let's say someone is refactoring, saying, this doesn't look good. Let me, the coding standard says we should do this. I don't know why, because the context, and a different constructor is being invoked, and now go figure what happened. Like the whole system behaves different because something else is initialized. Like there's a different code that is being, just because I did this parentheses. So pick your poison. I don't know what's better, but
could use double curly braces also.
So I said again,
double curly braces instead of parentheses plus curly brace.
Oh, double
like
curly
this?
braces.
Curly braces like this. I didn't try it actually. It's the same. Yeah, I didn't.
Is that happening because the inner curly braces are like an initializer, like a constructor for that list?
Yeah. So here's the thing. What do you think is P? What is the type of P? If you click on this CPP insight and you play it, you'll see that it's an initializer list int. Huh. This is a new thing in C++ 11, and it's really convenient. I can do something. I can do something like this. And sometimes either in unit test or maybe in a real code. And I can do something like see out. Or do whatever. Like I have a series of numbers that I know in compile time, and I do something with it. So it's very convenient way to have kind of a list, like an ad hoc list. So anyway,
and I'm just curious, what about just like A2? What if you did, instead of double parenthesis, you did just regular parentheses?
Here, there is no such thing. I'll show you. There's regular parentheses would not work here. Just I want to show you how the full loop looks like. So you see this initializer list. Now, if you try to do something like this, there is no such, like in other languages, yes, there is such syntax, but I'm afraid that would be actually it did. See, huh?
What on earth?
It's actually what it did. Okay. That is the comma operator. So what happened here is 1.2 comma 2 would give you 2, comma 3 would give you 3, comma 4 would give you 4. I actually never tried it, but here I just didn't realize that it's gonna work. But this is basically a comma thing.
So I'm sorry, on line 14, when we do A2, if you just do regular parenthesis instead of
like
curly brackets
inside like this,
as A2 open parenthesis close parenthesis.
Oh, like this. Oh,
yeah.
I have a Stack Overflow on that. I don't know. You actually guessed my next thing. Just coincident. You see this? I'm kind of giving away my next slide, but
That's why we have curly
yeah.
braces in the first place.
What's that again?
We can't do that, and that's why we have curly braces in the first place for initialization.
Yes. Okay, that you guys are actually it's a good segue to the next. I think it's the next slide. Is it? No, it's almost the next slide. So let's do this. Let me share quickly the next slide. Okay, go here. Okay, I just quickly wanted to share with you. So I don't know if you remember, but I am subscribed to some mailing list that every week provides a kind of a summary of all the important articles and posts that it was. I think LibHunt is one of them, and awesome C++ and things like that are what I'm referring to. So in addition, it provides all kinds of cool C++ related either GitHub or GitLab repositories. It's mostly coming from GitHub. So this actually caught my eyes, and I thought this is really cool to share with you. So let's say you have a struct, and this there is actually there is an example of how this directly taken directly from the GitHub README. So there is this even a base class, and you can say this is like the Python representation function underscore repair underscore. So so you can have a C instance of card, and you can say give me the representation. It would print this. That foo equal 5 because it was initialized to 5. 314 was bar, and then spades and ace, and it's a single header. It's a single header. Take a look. It's a single header. I don't know, 1,000 or 2,000 lines of code. Can't remember. I think it might be MIT. I can't remember. But it just, I don't know. Don't quote me on that. I can't remember the license. But very cool idea. I wanted to share with you. Very nice for debugging. At least my opinion is really nice. So I wanted to share this. The next one is kind of what we just talked about. So people actually, oh, what about this? So what we actually saw before that we just discussed with this parentheses is what we call the most vexing parse. The first time I actually got familiar with that was long time ago in one of Scott Meyer's book. One of his first books. It was like in the beginning of 2000, I think. And the idea is that I think every C++ developer should have at least one time that he or she gets this warning. It used to be very confusing in very older compilers. Now the warnings are much better. Because, oh, did you mean to do this and this? This is the most vexing parse. So the question was, what is the purpose of the most vexing? Why we have that? So there was a question of this is could be disambiguated as either as variable definition or function declaration. Why it's why is the majority of C++ but not make it a standard? Besides, like people think it should be a variable definition, taking an anonymous instance of class A. That's what everyone thinks, but actually the standard says it's a function declaration for a function which returns an object type and takes a single unnamed argument, which is a function returning type. So this is, but there's even much simpler example, just like we saw in the CPP Insight, where you have the capital A and then lowercase a and then parentheses. This is the most vexing parse. You actually not defining, but declaring a function. It's a function declaration. It's not definition yet. It's like a prototype of a function named A, returns capital A and takes no parameter. So the answer is pretty straightforward if you're actually thinking about it. What are the options? Like, you need to have a function declaration syntax that happen to be like, think about this a foo, right? How would you, if this is a valid function declaration, but you also want it to be a valid variable that just call a default constructor in this case, what would you do with the function declaration? If you think about it, you need a new keyword to distinguish between these two, right? Because otherwise you end up with, okay, this would be both, and now I need to have a specific keyword that says, oh, by the way, for a function named foo that takes no parameters and return a, I need the keyword that says this is actually a declaration. This is not a foo instance of a that just call a default constructor. And just like was mentioned before, the curly braces actually help with that. So that's the most vexing parse. Hopefully I managed to get at least one person less confused in the next time they see this error. The next one is a book recommendation. I actually have two of them. One is related to the next talk, and one is just something that I. So the CPP Cast is a very famous podcast that I'm listening to, and they had I don't know how to pronounce his name, Slobodan Dimitrovic. I don't know if I pronounced it correctly, but he was on the show, and I have a copy of that, and it's pretty good reference for beginners all the way to C++ 20. It's not really going in depth in a lot of things, but it would give you, and this is all, the book is written really well in terms of modern C++. So you can pick it up and have a very good, let's say, entry-level C++ and a bit above, all the way to 20 features. So recommended if you're trying to kind of find something which is relatively, it's kind of a thick book, but I really recommend if you're looking for something. This is absolute beginners, and it's really absolute beginners. Okay, I think we have time for 3 quick WalletFox drawings. So WalletFox is basically behind this. There is a person, I think, also living in Switzerland, if I'm not mistaken. WalletFox is one of the people that one of the person that I recommend looking at their website. They have a great ranges v3 booklet that you can have either shipped to you as a hard copy. I really recommend it. It's done very, very well, the graphics and all. And also there is as a soft copy. I have the hard copy, of course. I really enjoy it, and I use it as a reference when every time I need to go and do something with ranges v3. So take a look at his website. Okay, so take a look at this 2 options. You have, this is high order function, higher order function, basically a function that returns a function. So take a look at the lambda. So take a look at these 2 options. Take a look at this option that is not good. You have this ed, which is equal to a lambda, and inside the body of the lambda, we're returning another lambda. This another lambda is capturing whatever is needed inside. So one is a parameter, which is y. It's not captured. This is a parameter, but there is x. X is needed and is captured from outside, but it's captured by reference. So this parameter, so there's an argument that is passed, maybe through a register, maybe a stack. We don't know. It depends on the API, but it doesn't really matter. It is captured by reference. And now we have ed, and we can call ed. Ed is a function that has one parameter, and we can pass 1 as an argument. So what happens? It prints nonsense here and prints 10 here, and there is a nice kind of description of how the compiler takes this lambda and makes it a class. Remember, lambda is basically just a class with an operator, like a parenthesis operator, which is a callable object, basically. And what happens here is that this X, which is captured by reference, is a member by reference. And just remember, now we have add. It's basically a callable object that has internally some reference to something that died. This X died. There is no such thing anymore. And we have some reference to something that either used to be on the stack, but the stack is gone, or something that was on the like a reference to something in the register. Register is gone, like it has something else. It's nonsense. Equal means copy this value. Copy this value. Take a look at this class inner, and the integer X is just being it's a copy of whatever X being passed here. So I have this add1, I have this F, and then I can call F9. So Y would be the X would be this 1, and then F9 would be the actual Y. 9 would be Y, and it prints 10 because it's 9 plus 1. Okay, so that's, just remember in Lambda, just remember that you capture by reference lifetime. This is not Rust. It's not going to help you. The compiler is not going to help you. Maybe the static analyzer would, but just be careful about lifetime. Okay, this is C++. It's not going to help you. Okay. Another thing related to lifetime, which is less known, but is a very common issue that at least one you'll have this error at least once in your career as a C++ developer. Let's take a look at this one. So you have this opt, gives you a temporary, and then there is a dot value. This is not going to extend whatever whatever object that is passed as a return value in opt. Okay, so passing temporaries into range for loop like this relies on the lifetime extension, but there's no life extension for references sub-expression. The idea is the sub-expressions. So think about this optional value, then you get something, then that value, there is no extension of that. There is a paper that would, I don't know if it's got accepted or not. This is for C++20, so we can check if it's got accepted or not. If you look at this 0614, it might. But right now the workaround is not having a sub expression, but capture this as a separate variable and then do that value, and that would help you. By the way, the builder pattern, if you remember, I had this. I presented something similar a long time ago. The builder pattern is also have this gotcha, so just be careful how you use the builder pattern. Okay, the last one.
I have one comment for the previous one. So
yeah,
if that value returns a reference, you can actually use that for like on the left. That's the only exception.
Okay. Yeah. Yeah.
Alternatively, I think with C++20, you can now declare a variable inside the range-based for loop.
Right.
So the auto or equals opt, that can be brought right after the parenthesis after for.
Yeah. Yeah.
So it's cleaner, I suppose.
Yeah. Yeah. And the idea is really be careful with. So this is the implementation of opt. It can you see it's an R value, right? So it's a temporary, and that value is not going to be, there is no extension of this. Okay. The last one, it's very, very, very simple. It's a common issue on one hand, but on the other hand, it's one of the first things that you learn how to deal with. So if you have a transform function basically there's a lot of overloads, but in this example, it takes a range, v1 to v2, and some other range, and it it's mapping what we call in functional programming. It takes a value in each value in the range. It takes it, runs some function on it. The return value would be pushed into the new range or the new container. Okay, so for example, we want to take 1, 2, 3 and get 2, 4, 6. We times 2 everything. So just to be aware that if you take v2 and you just do stud begin of v2 has nothing, and this would be segmentation fault. It's kind of undefined behavior because there is no capacity yet in v2. Stud begin would be passed, and you start accessing because it's doing plus plus. You start accessing to an non-allocated memory. So it's basically it's gonna blow up. You start doing something which is not gonna be like you don't know which memory you're gonna start writing to. Okay. There are a few options to solve it. One is you can pre-allocate space, and then now it's fine because you are now stepping on a pre-allocated space. This is your memory and all good. But there's another option. So this is probably a very good in terms of performance-wise. You allocate once, you know how much to allocate, and you're done. There is this adapter back inserter, which would do basically, if you look inside, it's doing pushback. And pushback would dynamically grow the capacity. It would copy or move the values as needed every time it needs to expand. So it would incur maybe few of, depends on the size that we need, few allocation. So it's less efficient than this one, but it's still defined compared to the first one. Okay, so that's it for this one. Before we go to the main course, give me a sec. I'll get my other slide that mostly Martin and I have a very just a few slides in the beginning that we prepared for you.
I think you have twice as many as me, so.
And again, I think you missed my first a few minutes, and this is all based on, it's an idea based on a post that you had. I don't know if you have the post link. If not, we can put it in the chat. I think this is a very good introduction to concept. If you were thinking, oh, what is this concept that everyone talking about? I think this would help you a lot. So give me a sec. Just get it done. Okay. So I don't know if it's a good name or not. I basically, the way I look at it is, let me just share it in there, is when we approach concept is it's much larger. I think I'm missing one slide for my overall. I wanted to talk about, give me a sec. Okay, give me a sec. There is one thing that I wanted to talk about, and I think I missed that. I said I have two books. So there is one book that is, oh, okay. Okay, here it is. I had two more slides on my previous one. Okay, so before we move to concept, I wanted to kind of have a shout out on Elements of Programming by Alexander Stepanov. You should, and Paul McJones, you should be at least here familiar with Alexander Stepanov. There is a podcast which I can't remember which one I was listening to. I can't remember. It might be related to functional programming podcast. I can't remember, but there was a full it might be a CPP cast as well. There was a full session about a full podcast about a work done based on Alexander Stepanov, and I actually was very curious about this book, and I picked it up, and I was kind of amazed. Like this book, I think, is kind of old. I can't remember what year, but when I was start looking at it, I was kind of astonished to see that this has concept. And I said, okay, I thought concept is relatively new. I know that Brianna is pushing for that, but I didn't realize that there is a book on concept. And like kind of skimming through the book, looking at a few of the pages, Alexander Stepanov basically is all about generic programming. You can definitely know that he was the father of the STL, the standard template library, and this whole idea was about generic programming and having the mathematical describing this in like he is a amazing person, by the way, if you read his bio, and so I'm hoping I'm not kind of just telling you just a thin of his bio. He has a lot of things that he's doing, but just specifically on the STL and the elements of programming, he managed to kind of take the idea of describing mathematical concept and all into STL in terms of ranges and all. It's a very fascinating. I need to find this podcast and maybe post it in the meetup. It's a very fascinating 1 hour to listen about Stepanov and his work and elements of programming. Very inspiring. So I was actually amazed. Oh, there is a book on concept, because I was looking for like a long time ago. I think it was last year. I was looking for a book on concept and just happened to pick this one. And I was looking through these pages that, oh, there is a book on concept. Like everything almost is concept. So yeah, this is not a new thing. And he actually was all about generic and describing all kinds of, I don't want to use the word concept, but describing all kinds of elements that would be generic and very readable and very easy to reason about when you read a function and it has that kind of a prereq on the types. So that's what I wanted to share with you. So let's go back to my other slide deck. Okay. So when I came up with this idea thanks to Martin's post, and I encourage you to look at Martin's blog. There's millions of stuff there, very interesting stuff that can help you on your daily job, or just if you want to broaden your horizons in C++. So it's a great thing to look at. I actually was thinking about a very kind of an intro level, and maybe give you some of my opinions, at least the first few slides that I present, and Martin would present his slides. My opinion about how to approach that and why do we need that. But by all means, it's not the official approach or official opinion from the start. It's really my opinion. Like most of the things and all the things in the meetup is kind of my own opinion. Okay, so outline is the old syntax. We talk about the templates, static asserts, and so on and so forth. And then Martin would talk about the new shiny syntax in 20. So let's talk about templates. So templates, we have, it's not really a talk about templates, though this is the major thing, but templates is way something much broader that we can talk about. But templates in a nutshell, there is for functions, and there's also for class types. Okay, so class structs, but also for functions. And technically speaking, there is at least two options. There is a types and non-types. I don't know if there is a third one. I would say I don't. If there is, I don't remember from the top of my head. But let's say there are types. So you can see here there are two options. There's type name T, and you can see also in the books class in terms of type name. Class was just to say it's just a type. It's kind of a class type, but then later say, okay, type name is much more readable, but class is definitely applicable here. So type name T, so there is a T here that is being used. There is a type that we can instantiate this class to be in any type, for example, an integer or a string or whatever. And there you can also have non-types, like a boolean or an integer or enum. So you can have non-type, and this is very useful if you want to have, like, think about all the type traits that I used to show you. There's a lot of non-types classes and structs there. So that's one thing. And the same deal about functions. And there's a small comment here that this could be also if const expr, if it's a constant, but it doesn't really matter. The idea here is that there are templates for function and for classes. Now, let me introduce static asserts, though I already used it in many of my slides. In my opinion, this is all my opinion. I think static assert is not the best name. I've never seen anyone kind of saying something else, but in my opinion, the word static or the keyword static is too kind of overloaded in C and C++. It's being used in too many. In my opinion, it should be compile time asserts, but that's my opinion. The idea behind it is that in compile time, I can have all kinds of checks and see if my compile time assumptions, and it's all compile time. There's nothing in runtime. If my assumptions are broken or invalid. It was introduced in C++ 11 and had some improvements. For example, in 11, you couldn't make any string message. If it fails, you couldn't omit anything. But in 14, you can omit a string message. Oh, this is failed. This assertion has failed. So in 14, there is a kind of an addition. It's a very useful method before 20 to validate all kinds of template types and non-template types parameters. It can be used, it's very handy. It can be used inside function declaration, outside of function members body. It's a very convenient tool that I personally use in my template code. Sorry. So basically you can place requirements on constraint on types and also values. There was a question mark, but yeah, it's also on values. And basically the old fashioned was to have this constraint on template with either static asserts, heavily used in, can heavily use type traits. There's also, I show Sphena, it's another way that I can see as, okay, I'm constraining something to a specific behavior and that's it. It's not the same as static assert, by the way, but it's another, when I kind of came up with the slides, I said, what else I can think about that I can play with templates, and substitution failure is not an error, is another thing. I'm not going to explain Sphena, and I know that a lot of people, including Bjarne himself, doesn't really like Sphena. I remember, again, I have this story when in 2006, I met him in one of the workshops in Santa Clara, and I asked him, what do you think about Sphena? I think I learned about Sphena like a few years back, and he was like, you know, Sphena, you should not know about it. This is too complicated. We should not do that. Like Bjarne doesn't like this complicated stuff. He likes to do something which is much simpler. So, but it's a tool. It's a tool like everything that everyone is using. So it's part of the language. It's primitive, but it works well for us. Like both options, like the static asserts and maybe Sphena. For example, here's a function. I have this t, and if it's initialized, if the function is being instantiated with t as a pointer, I can say, hey, this should not be a pointer. This is a type trait under the type trait header, and I can say you cannot use it. More examples, I can have an object, whatever a class, and I can validate that this is not a copy constructible. It's not copy assignable. It's not movable. It's not a move assignable. I can have all of that. This is a C++ 11 syntax. C++ 14 has an additional message, just like this one. This one is a C++ 14. Super handy. And I can also have it done on all kinds of non-types. So I have bits, I have number of elements, I have t, and I can do all kind of checks to see that the size of t is more than bits, or the elements are some constant x per value. Very, very handy if I want to make sure that my assumptions when I write the object and someone is instantiating it, it's instantiating it correctly. So I mentioned Sphene. I just want to show it something related to it. But let's say I have this function. I have a single function, and I really want it to be instantiated or being used only with an integral type. I can play with it in a way. So there is this enable if, where I can say, if it's an integral, there's going to be something, and it's not like the compiler is not going to fail in substitution, and this function would be available. It's going to be either declared or defined, doesn't really matter right now, but it's going to be available. But if I have 42.0, this function is gone. And if it's the only function and there is no other overload with double or float or something similar, there's going to be an error. So it's not really like static asserts, but it's another tool that you can use. Okay, I have a couple slides before we go to Martin's slides. So in general, the static asserts error messages are okay. It worked well. You can have user-defined messages that will be omitted in C++ 14. But the problem that at least I see here, and again, I'm not a committee member, and again, my opinion, they're not really higher concepts. Sorry about the pun. There is no something that I can build, or I can build a readable, again, I can't use concept here, but a readable syntax or a readable expression that has something more meaningful behind it. It's all kind of ad hoc. And the idea behind concept that you'll see in a moment, the cool part is that you can have like small building blocks that you can assemble like a Lego, and it's pretty nice. And you can have something really readable that says this should be like this, and it's also helped the error messages. Compiler error messages are much they're much easier to grok. Take a look at this. If you put it in gold bold, I'm not going to click this link, but it's very kind of a messy messages. You cannot sort using a std list. There is a some prereq that are needed. And if I had a concept that says you can have sort only with sortable, and sortable is I need this kind of iterator, then things would be much easier to read and much easier to express. Now, yeah, I mentioned that before. There's some work being done by other people to kind of take this whole thing that the compiler is omitting and try to digest it in a much more simplified way. So this is a GitHub that I mentioned before, but it's not really the right thing to do. The right thing to do is something part of the language. So this is, so Martin, do you want me just to flip, or do you want to take over?
Yeah, you can flip through slides.
Flip. Okay, so you tell me next or not, and I'll
okay.
So what I'm going to do, by the way, I'm going to close my feed so you can have your feed.
Okay. Yeah, so hi everyone. My name is Martin Vorbrodt. Kobi, thank you for letting me speak today. Go ahead to the next slide, please.
Let me see. Okay, here.
There we go. Okay. Yeah, so everything Kobi discussed and presented so far was, you could say it was a hack, or another mechanism of the language was used to sort of put restrictions and requirements on a type, but frankly, none of it really was specifically designed for that purpose. So with C++20, we now have a mechanism designed for this explicit purpose through new language keywords. And it can be applied to functions, classes, member functions, as well as variables, as I will show you. It's pretty neat. Next slide. Kobi? Oh, there we go. Okay. No, that's not. Yeah, go to the next slide.
Yeah, it's not cooperating for some reason. Okay, now it's fine.
Okay,
I'm
there
trying to watch your feed while I'm looking at it, so in a different screen, and it's not working. So that's fine.
No worries. So what is a concept, right? It's something from a high level point of view. It's something that needs to evaluate to either true or false. If it evaluates to true, that means that the type that you ask the concept to evaluate has been accepted and passed its requirements. And if it fails, then means the type is rejected by the concept, and you will get a much cleaner compile time errors, as Kobi mentioned. You won't be looking at this total gibberish from the compiler, but it will say, hey, I failed to compile this line of code where you're instantiating this template with this type because it fails to meet this and this criteria, and it actually names a concept for you. And here on the screen, you see the most basic form of a concept, frankly, pretty useless, but just to illustrate the syntax and how you define them. I have an always true and always false concept in the first two lines, and you see that they are just hard-coded to true and false. And another syntax there, the last two lines define the same thing, but they use the new requires keyword as well. And I will talk more about the requires keyword on the next slide or two, I think. Go ahead, Kobi, switch to the next slide. Okay, and this is how we can apply these the simple concepts using now the requires keyword. So where before, you had a function called good or bad, that was a template function. Now you can add the requires and always true for the given type t. And we know this will always compile because this type is hard-coded to true. Or you can have a bad function that says requires always false, and regardless of what t you're going to put in there, it will always evaluate to false, so it will never compile. And below, another example is how to define a structure. There is a template struct, which requires type t to be an integral type. std integral is part of the C++20 concepts library, and it's one of many concepts that are defined for you in the 20 standard. Go ahead to the next slide, Kobi. Okay, let's define a slightly more meaningful concept. And here you will see that the requires keyword has actually different meanings depending on the context, and it's sometimes counterintuitive, but once you get a feel for it, you'll see what I mean. So a concept, as I showed you on the previous slides, can be a simple expression, or it can be a composite of expressions and other concepts also. Concepts allow you to define optional variables, which you can use, and this will be important in a second. I'll tell you why. It's sort of like std decal val for decal value. It's a std function that declares a value, but it's never really compiled. This code never executes, but it's done for the purpose of type matching. And here, notice in the first concept on the left, that is using, it says requires std integral of t versus std is integral. So std integral is a concept. std is integral is a type trait. So there's this distinction. So looking at the concept on the left, in the box on the left, you'll see that I define a concept called can add. And at the very end of this first line, I define a helper variable called a of the type t, whatever t may be. And on the third line, you'll see that it says requires std integral t with a semicolon. That means, okay, I'm building this can add concept. It's a composite of other concepts. And the first thing is it needs to be integral. Second, the next requires tells you that size of t is to be greater than or equal to size of int. Okay, so not only is it an integral type, but also needs to be of certain size, at least as big as int. And then the last line there, and there's a lot to unpack there. So first, you will notice that there's no requires keyword, because what follows after requires is evaluated as an expression, as a Boolean expression, and it must evaluate to true. Without the requires keyword, when you declare, a statement like on that last line, it tells the concept to check whether or not this is a valid syntax. Will this compile per language rules? But it will not try to evaluate it further. And in this case of the last line, I say that I want a plus a to be a valid syntax, and you put it in curly braces. That's without a semicolon there. That's just the way the grammar for it works. I want that the operation a plus a to not throw any exceptions. That's why I have the no except there. And finally, the arrow, and it's just a minus and a greater to sign, but I took screenshots from CLion, which uses these fancy graphics. And finally, that arrow says something about the return type, and that means that std same as says that whatever a plus a returns, I want it to be the same type as t, or in this case as a, right? One thing to keep in mind here, same as it's a concept that actually takes, I think it's a concept, or maybe it's a trait, I'm not sure. But I know that it does accept two template parameters, and somehow one of them is defaulted. I'm not sure how exactly that's done. I haven't looked into it, but just an interesting tidbit there about same as. Now, looking at the concept on the right side, I'm defining a second concept called can sub or can subtract. Similarly, requires clause, a helper variable of t, and then the next line, the requires, I'd say that, okay, the very first thing I'm saying is that, well, it has to first of all meet the can add concept before you can do anything else. Then on the next line, where I say a times -1, no except, std same as t, that means that a times -1, or negating, right, of the variable, must be a valid expression, that it must not throw exceptions, and its result must be the same as t. And finally, on the last line, I'm also declaring that a function add, which I did not include a definition for here, but just as an example, function add operating on type t, if it took a and a twice, has to throw no exceptions and also return same type as t. Go ahead to the next slide, Kobi, please.
So I also didn't know if same as, like, is it a concept, is it a trait? So same as you said is a concept.
It's a concept.
And
okay.
There is same, which is a trait.
It's a trait, right?
So,
yeah,
so there is is same, which takes it's a template of two template parameters. So is same, let's say int and float would be false, and same as is a concept.
Okay. Does same as also take two template parameters, with one being defaulted, or was I confusing the two?
Same as it takes. Let me see.
Same as, yeah, as a concept.
It takes two parameters.
Takes two.
Parameters.
Yeah, it takes two.
Okay, and one is somehow defaulted there.
I don't see it on CPP reference.
That's all right. We can look at it afterwards.
But if it's again, if it's first time I'm looking at same as, so
I mean, same as from the name, it should be binary operation, right? So it needs two.
Right. Mm-hmm. Yeah, that's what I remember reading about it. And there was some explanation why there's only one type T provided to it here when declaring concept. That second type somehow is injected there, but I cannot think of it
I
off of
see.
my head.
Okay.
Well,
Yeah.
in this case, there is no way to specify what the second one is going to be. So the compiler has to do it on its own, no?
Yeah, the compiler does. So the compiler will evaluate the statement on the left of the arrow, the a times -1 or the a plus a, will decide what its type is, and then plug that into same as the first parameter, I think. And then you provide the second. But how exactly?
Yeah, but what I'm saying is that it has to be done that way, because otherwise we have no way to specify what is the second type for same as.
Yes, that's right. Yeah, because here the second type for same as is the return type, which we don't know. We're only stating that it needs to be the same.
So the next question then is, which one is going to be replaced? The first one or the second one?
I don't know, but I don't think it really matters.
No, in this case, it doesn't matter, but for other concept, it might matter which one is first, like to have a derived from kind of stuff.
Right.
So the question now would be, from the concept, when the compiler replaces the type, is T here the first or the second type of the concept?
Mm-hmm. Yeah, maybe I'll try to look it up on the side later once I'm done with these slides. You can go ahead, go to next slide, Kobi. Okay, so let's continue defining a more meaningful concept. You see that there's a second requires there in the concept that's shown in the bottom. If you want to merge two concepts together, right, in there. So you can say requires can add of T and can subtract of T, or you could say requires can add or can subtract. So that's a Boolean, logic composition of two concepts, and the requires keyword is required there. Let's see, and omitting the requires keyword changes the meaning of each line, separated by a semicolon in a concept, in like a nested concept. And it changes the meaning from, evaluate this to true or false at compile time to is this a valid expression? So you could, for example, let's look at the last line, right, where it says requires, and then std is no throw invocable r_v. So with a return value and a v is just an alias. It would normally be is no throw invocable _r : value, but in the standard they have these helper _v aliases. In any case, so requires that whole thing, with the parameters of t on a function sub, so subtracting function. It states that, well, the function subtract on t, called with two parameters t, has to return t and must not throw an exception. That's what the concept mechanism would try to evaluate. Now, if you remove that requires keyword from the last line, it would completely change the meaning of it, saying is this a valid statement? And it absolutely is a valid statement. It doesn't do anything, but it will compile. And you can try this. You can copy that whole line, paste it inside your main function, remove requires keyword, compile it, and it's just going to say, yeah, maybe it's like you're just referring to a variable or something, but it's completely useless. Alternatively, the middle line in there, so it'll be 1, 2, third line of actual code where there's a sub t a comma a. That's also another way to define the same thing. So here we're stating, here we don't need the requires. Here we're saying that, yeah, calling subtract with two parameters must not throw an exception, must return the same type. So basically the last lines are more or less equivalent. Yeah, except the middle one is a newer, cleaner syntax that does not rely on the type traits library, but it uses concepts exclusively. Let's see. Okay, go ahead to the next slide, Kobi. Okay, and then let's talk about how to apply concepts to functions, for example. So you may need to use the requires keyword. You may not, and I'll explain in a second why. So the first example applies one concept using requires keyword to a function called add, which is a template. So you'll see that following the template and type name list, here just one type T, we say requires can add of T. So that's just one type that's applied to add. And whatever can add is, it can be simple concept or it can be a composite of many. It doesn't matter. Alternatively, in C++20, the syntax has also been changed and made. Let's see. No, I'm sorry. I'm jumping ahead. I was thinking about the third part, but I'm looking at the second. Okay. The second example, applying multiple concepts with requires, you need the parentheses there. At least according to every compiler I tried. That was a strange requirement there, change. So you'll see that after the template declaration, it says requires and it has to be an integral and a size of that type has to be greater than 4. And I omitted the rest there. That could have been a function or something. And finally, the new syntax allows us to remove type name and replace it with the concept name itself. So you will see template and then can sub of T. So there's no more type name, and it's a neat way of naming, specifying your type for the template while simultaneously expressing it or applying a concept to it. So at this case, there is no requires keyword needed at all because we removed type name, replaced it with a concept, and again, nice and short syntax. Go ahead to the next slide, Kobi. Let's see. Finally, yeah, I wanted to add that concepts can be applied to variables in a variety of ways. And I have a simple example here where I'm using integral and floating point concepts from the concepts header file to restrict a variable type. So I'll say std integral auto I in the first line of the first example, right, equals 11. And it's it's pretty obvious here, but this 11 could be replaced with a macro or something else. In this case, you would be able to guard, what that auto I variable is actually initialized with. Similarly, floating point twice for f variable f and d. Although it's a concept that will be satisfied for either float or double. And maybe more useful example is the second one, where I declare a template function QAZ, and it's just a simple pass-through. Takes T, returns T, so its return type is whatever was passed. But then I can illustrate the application of concept to a variable by stating std integral auto g_I equals QAZ. So I'm calling this function, which 3, which is an integer. It's going to return it, and it's going to satisfy this concept. Now, if instead on that line with the g_I variable, I called QAZ with a floating point, it would fail. Again, this is a simple example, and you can see exactly what the type is because it's hard-coded, but that may not always be the case. So it's a nice way of restricting, not only the parameter types, but also applying this to local or global variable. Go ahead to the next slide, Kobi. That's it. Thank you. And by the way, here's a link. Kobi mentioned an article I wrote about it. I've been blogging for about 2.5 years now, just for fun, mostly to document my learning progress as I learn modern C++ and just to share the knowledge. So here's a link to the article. It has many more examples and a more complete source code, which you will obviously need C++20 to compile. So that's it for me.
Thank you so much. Thanks, Martin. Thanks a lot. It was very interesting. Yeah, this concludes our meeting. Is there any question or anything that people want to bring up before we conclude this?
Thank you, Kobi, for this very comprehensive session. Just wonder, you shared a lot of links. It would be great if we can have the slides shared.
Yes.
Follow the links.
Yeah. So remember, it's all in the Dropbox. If you don't find it, please don't hesitate to contact me. Okay, I can share it. I can share the link again, and please don't hesitate. Just go to the Dropbox, download the slide deck, and let me know. You can contact me through meetup. People already doing it, so feel free just to contact me and bother me as much as you want. This is perfectly okay. Okay.
Thanks.
Thanks, everyone. Have a good
Yeah,
day.
Kobi, you will upload it to YouTube eventually, right? Today's
Yes.
recording.
Yes,
Okay.
yes, I'm gonna
Yeah,
upload.
I will also link to it on my blog.
Thanks.
So I'll copy if you put in if you include an agenda in the description,
Okay.
I'll copy it and I can copy links to slides and everything else.
Okay, thanks. Appreciate it. Thanks.
Awesome.
Thank
Thank you,
Thank
Kobi.
you again for the talk. Thank you, everyone. Have a good rest of your week.
Thank you, Martin. Thank you, Kobi. Bye-bye.
Thank you.
Bye, guys.
Have a great week.